All right, let's go over our objectives. At the conclusion of this lesson, you should be able to describe the best uses of a cordless drill and impact drill. We'll cover a few tips with these tools. Next, identify different types of bits, tips, and screws. We'll go over a few things related to these. Then explain the significance of the term square. What does that mean, and why is that so important in carpentry? Compare the methods of squaring a project. We'll learn about the term square, and we'll learn about different methods of squaring. You need different ways that'll be determined by the size of the project most of the time. It's a few different ways to do it, and it's good to know different ways to do things. Next will be calculate angles for polygons. We'll learn how to find the correct angles for projects that have different shapes, different amounts of sides. We'll look over a few different types of projects that have different angles, just to get you familiar with that. Let's get started. All right, the first thing that we'll get into is a little bit about tools. We're going to discuss some tips on the cordless drill and the impact drill. There may be a few features and ways that you can use it that you may not know. One feature is speed. You have two speeds. You got a low speed and you got a high speed. I tend to, this is my preference, if I'm running screws, using it for a screw gun, I like to put it on low speed. If I'm drilling holes, I like to put it on high speed. The chuck is a keyless chuck. You just hold it, and to put it in reverse to take a bit out, put it in forward with that button. Try to hold the bit in the center and bump it until it tightens up, and then you just hold it, and that tightens it up. One thing that you might not be aware of is these numbers. This is called a clutch. What it does, if you turn it all the way down to the first set in 1, it takes hardly no pressure to keep it from turning. The higher you turn the clutch up, the more torque you got. Or if you get it almost all the way up, it's hard to stop it. And then it's got a bit setting where if you are drilling, ow, excuse me. Oops, that screw went all the way through. I had the chuck setting very high. So if you screwing a lot of the same type of material down, you can turn this chuck way back. I can tighten it up. Alright, say that setting right there is going to do it. So I can set my chuck to where it will make my screw tighten up to the depth that I want it to be. You won't pull all the way through, or maybe you might have it set too light, it don't pull it down deep enough. So you can set the torque to adjust the depth of the screw. Now I talk a lot about pre-drilling. It's something that you can do most often You know, at times pre-drilling wouldn't be practical. Say if you're putting a decking down 5/4 by 6-inch boards on a deck, and you got thousands of screws to drive, you're not going to pre-drill it. But they make screws for that. The reason you want to pre-drill is a couple of different reasons. One thing, it'll keep it from splitting on the ends. Another thing is it helps when you start the screw. So if you don't already have a hole, there's no hole there, you have a little harder time sometimes getting that screw started. Alright, you got to hold it with your hand upright. Alright, we got it started. It's already trying to split that board out there on the end. See it? Look at it splitting. Oh. But if you pre-drill it, how much time did you spend pre-drilling versus the time it's going to save you and the aggravation? Alright, that was a lot easier. And you didn't worry about it splitting on the end. One thing I see in amateurs is allowing the tip to spin. In other words, this tip goes into the end and you driving the screw in, and the tip spins in the screw and it just eats it out. See if I can show you an example. So when you're running this screw with a cordless drill, you want to make sure you keep enough pressure down that you don't allow the torque to push the tip out of the screw a little bit. You got to bump it. All right, see, I didn't pre-drill it, it's already splitting. All right, let's do it again. Maybe I'm not putting enough pressure on it. Hear it spinning. It'll wear your tip out if you allow this tip not to be all the way in there and the tip spinning and the screw's not spinning. It's just wearing your tip out and it's wearing the head out on the screw. So you want to make sure if you're running these screws that you don't allow, hear it? You don't want to allow that to happen. You want to make sure you keep enough pressure that when you just bump it, don't. Let me show another example. Try it again. That's another time you didn't pre-drill. I'm going to pre-drill holes here. We're allowing that tip to spin. It's going to wear your tip out. It's going to wear that head out on that screw to where you can't screw it in anymore because the tip's worn out. So you want to make sure you, instead of just pulling the trigger and running it in fast, you want to bump it in like this. That's how you want to run a screw with a cordless drill. Now, if you got one of these, this is another great tool to have. Now, your cordless drill is very important. I use it for usually pre-drilling, putting a bit in there, drilling holes. And when you pre-drill, you just want your bit to be
about the same size as your shank here on your drill. And it doesn't have to be perfect. It can be loose enough that the screw can go all the way through it, or it can be to where you can't push a screw through it, just like this. But you've gotten rid of some of that to where it's not quite as much of a bite. But this tool is better than the cordless drill. This is called an impact drill, made for running screws. It doesn't have a chuck on it. It's got a quick release. You just pull this out, insert your tip, it's ready to go. And it'll really, it's got a lot more torque to it. It'll run a screw very fast, and it'll pull it up very tight quickly. This impact drill really is a good tool to have. Let me put a bigger screw in just to give you an idea of how much power this thing is. This screw here, you may struggle a little bit with the cordless drill to get a screw this big in, but with this impact drill, no problem. Alright, you got different type of drill bits that you use too. This type of drill bit we use a lot. These are two very common types of drill bits. These are called twist drill bits because they're made in the shape of a twist. Now these usually are good for wood or metal, and you can get them in different grades or quality that may allow them to drill better in metal, but these are good for metal and wood. And for drilling small holes, this is what you need. Then you got what some people call them spade bits, some people call them butterfly bits, but these are strictly for wood. And they'll go, you know, like my set goes from 1/4 all the way up to 1.5 inches. So you got a big variety of sizes that you can use easily, you know, to drill wood. One thing you want to keep in mind is they dull very easily, so if you were to hit anything that's not wood, if you're drilling a piece of wood with these and happen to hit a screw or a nail, it's going to dull it very quick. If you're drilling and it drills into the dirt, say you're drilling outside, if you let it go through into the dirt, that's going to dull it. So take care of them. Like with a set like this, it keeps them all separated and secure, and you don't have to worry about the bits banging together. So you can just keep it in your toolbox, and you don't have to worry about hitting any other metal and dulling them up. But they work real good. And then we got different types of tips that we use, different types of screws and different types of tips that we use for those screws. One tip that you see is a standard straight slotted tip for a standard straight slotted screw. And if it's any way possible, you don't want to ever have to use this. Why is that? Because as you turn, this tip continuously try to slide out of the slot. It's just it was I guess one of the first screws invented, and it is not practical. So keep it in case you have to use it for an old screw, but you don't ever want to go buy slotted screws. The next screw up would be the Phillips tip. A big step from a straight slot to a Phillips tip. Now the Phillips tip comes in different sizes, and you need to make sure, you know, you match up your tip with the screw. You may have a small screw with a very small head So you would use a very small tip. And just always match them up to see if they fit tight, snug. If they loose, then you need to go up to a bigger tip. But these tips come in sizes. These are the most standard. A number 1 Phillips, a number 2 Phillips, the number 3. See how much bigger the tip is on it? Or the most common is the number 2 tip, number 2 screw, and it fits good and snug. And the snugger that tip fits into that head of that screw, it's going to tighten it up better. It's not going to slip. You see these two, they both are similar, but a little different. They're both Phillips. This is a Phillips head we just talked about. This is what they call a combination screw. You can use a Phillips tip with it. Now some of them are made for a number 3 Phillips tip, some made for number 2. So that number 2 will fit in there, and you could use that in your drill. It's not as good as a square tip. See how it looks? The square tip in its combination, that's why they call it a combination. It'll work with a Phillips, but it'll also work with a square tip. Square tip fits in the middle, and that's a good tight fit. This will be my second choice probably to the type of tip and screw I would use. But I'm trying to phase these out, trying to get rid of all my combinations, because my newest love is the Torx tip. See that Torx tip? It looks like a star. That is the best tip you can buy at this point. That's affordable. When you get this tip fitting in the head of that screw good, it's not going to slip. And that's what you want. You want it to fit real tight to where when you're torquing a big screw down, it don't slip. That is key. Now, with that in mind, you got some different sizes of Torx screws. All right, that one fits good. So if you look, I don't know, can you see it? It says 25. That's a number 25 Torx tip. Say we got this screw. I mean, really, you could look at it, and to the untrained eye, it looks like that tip should fit that screw. But that tip is a little bit too big, it won't fit in there. So we got to drop down to this tip. That fits it good. That, you know, you can see it, is a number 20. So this is a 25. This is a 20. And they fit these two screws. Now you can go up to a 30. You can go down to a 15. And they go down to 10, 5. These go up to 35, 40, 45, 50. But this Torx, that's what you want to use. These are the good ones. This is a magnetic tip holder. These tips are a little longer, and you don't have to have a holder for them. With these short tips, you need a holder for them, and you can drop it in your tip holder. And like I said, this is magnetic, which makes it handy to keep from dropping your bits. Number 4 rebar is a 1/2 inch, right? So I wanted to go at least 1/16 bigger, so I'm using a 9/16 bit. That's 1/16 more than a 1/2 inch. A couple of reasons. One is, no matter how good you are, those holes are not going to be perfect as far as in line. So with when you go to drive your rebar through. That gives you a 1/16 inch to play with. Plus, when you drill into wood, it's going to have little fibers still sticking out. So if you drill a 1/2 inch hole, that's going to be a tight 1/2 inch. So if we go a 1/16 bigger, that should give us a little room to play. One tool that you use quite often, and we will be using it a lot on our project, is a cordless drill. A cordless drill, very simple tool to use, but
We're about to start putting together our first raised garden bed here. As you see, we got us a little work area set up. Sometimes you just have to create you a spot or a table. For instance, here, the table that I'm using, it wasn't long enough or wide enough for the raised garden beds. The raised beds are 4 foot by 8 foot. Well, this table was only like 30 inches and 6 foot long. And you know, you may run into this at times where you need to make you up some kind of workstation. You can take some saw benches and you know, you could do the same thing. Like here, I took 2 landscape timbers, see these long landscape timbers here, and laid them on the table. Well, that made it long enough, but it wasn't wide enough. So then I laid 2 more right here, crossways here, and you can barely see this one, you know, goes across underneath. There's the end of it. And then we laid, you know, it was long enough and wide enough then to start putting our raised garden beds together. So then we started, you know, laying the garden bed pieces on top of what we had there. And that's how we got started.
I'm about to put together the first raised garden bed. Already clamped together the first row. Took clamps, put them up under here, pull it together so the joints will be nice and tight. Then what we want to do is drill right here in the center of every corner so the rebar can go through. I made this jig. It's something to help you instead of having to measure every time to try to get the center point of each one of these. We made up a little device out of wood, went in and drilled a hole. Now all I have to do is put it on the corner and just drill through the hole every time. We don't have to measure it. Let's go ahead and try one. When you drill it, you want to make sure you're as vertical as possible. And the best way to do that when you freehand it like this is just try to keep the bit in the center of this hole. Alright, that's the first one. You also want to be sure, after you drill in a little while, don't touch. I cut some slats, some little short boards that'll be the height of the whole bed when it's all done. And what I'll do is put them here and here on each corner to, as I add to it, to hold the timbers in place. As soon as I finished putting them on, I realized one of them was going to be in the way of my jig. So guess what? That should be fine. All right, it's time to start with our second layer. All right, we did pretty good today, but it's after 9 o'clock. I'm kind of tired, and I suffered severe injury, so I'm gonna call it a night. we're ready to put our last row on. I already got my end pieces set in place, so we'll just go ahead and get our sides ready. The only thing left now is drill these last 2 holes for the center. Then we got to cut our rebar, drive it in, and this one will be done. Easy. All right, this thing is 4 feet long. So, 8 feet long, so half of it will be 4, right? All right, then we got to get the center right here. It's 2 3/4. So what's the center of 2 3/4? Let me get my notebook out. All right, 2 3/4. We need to divide that in 2 because we need to get the center. 2 3/4 divided by 2 will be the center. All right. Easy way to do it. Anytime you want half of a fraction, double the bottom number. All right. So we want to get half of this. So half of 2, we know is 1. Half of 3/4, double the bottom number. 3/8. So half of 2 3/4 is 1 3/8. Right there on the old crack. It's already marked. Half of this is right there. Alright, we just got a couple more of these to drive in, and we'll be done. Start with this. I think there's a hole down there. There we go. And I want to leave them up until we get them in place, and I'll drive them in the ground. One more. All right. Had to turn the camera off. It got ugly for a little while. And what happened, this piece of wood here is almost a 1/4 inch narrower than some of the others. When I made my jig, I measured from the outside in. Alright, well, all of them not the same size. I didn't think about that. I should have made this thing to come from the inside out, because the only thing constant is where these come together. Outside they can vary. So what I'm having to do here is take a wedge and drive this out and get it flush with the outside here, so this rod will go through. Now, next time that won't happen, because I'm gonna make a jig. Instead of my catch bar being on the outside, I'm gonna make it where it pulls from the inside. That way it doesn't matter how much thicker or thinner any one of these boards are. I'm coming from the inside corner, and they always come together right there. So, problem solved, but I don't like having these kind of problems. I'm about to go set this one. Put some dirt in it.